Metro Supply Chain is the official sponsor of the Ask the Experts Theater at Edge 23, pioneering the future of supply chain with investments in advanced automation, robotics, and business intelligence. Metro Supply Chain delivers innovative, real-world supply chain solutions that advance business. Learn more at metroscg.com.
Hello. Welcome to the Ask the Expert Theater, sponsored by Metro Supply Chain. Metro Supply Chain is the largest privately owned logistics company in Canada. We have about 100 locations between Canada, the US, and the UK. My name is Sarah. I am the Senior Director of Sales for the US, and it is my pleasure to welcome you and to welcome Eric.
Thank you. Hello, everyone. Thank you for coming. My name is Eric Harty. I'm Senior Director of Strategic Initiatives at Zebra Robotics, Zebra Robotics Automation. Zebra acquired Fetch Robotics roughly about 2.5 years ago. And I had worked with Fetch prior, reselling them when I was at Intelligrated. And now I've joined over at Zebra, and I'm excited to kind of walk you through some different options here for AMRs, or mobile robots in general here. So what I'm going to touch on first, so generally when looking at it in the supply chain or a warehouse, you want to look across your value stream here. And what I'm showing, the value stream being from receiving, storage, replenishment, picking, sorting, VAS or value-added services, packing and shipping. And then what I've shown down below are the various AMRs that can fit in these areas. I'm not saying these are the only places they fit, but in general where we see their applicability. So here, there's this is a Forte AMR. This is from Fox Robotics. That's used for trailer unloading. If it's pallet loaded, it can move pallets in and out, but actually, sorry, only at this point out of the trailer. They're working on moving it into the trailer. And then for Pertaway, I'm showing here a robot from Third Wave Automation, who's sitting right over here. That is a reach truck, which can pick up a pallet and put it up into the storage area there. It can also do the reverse. In addition, when you take a look at storage and picking, this is where your options kind of get a little more varied. We have Kiva-like solutions or goods-to-person solutions. You also have cart connect robots or shelving robots, and then person to goods, which is where you're picking into those robots as well. Then once you get into the sorting area, there are different sortation robots that you can buy as well. And then pack out and delivery, generally you're moving pallets in those locations, and there's a different type of robots or AMRs that can be used there. So I do want to keep this interactive, so feel free to ask questions as we go. So one of the things we put in the presentation or the pitch for this was trying to dispel the acronyms for you. What you have here, we're going to talk some of the basics. So AGVs versus AMRs. What you have on the left here are AGVs. So those are automated guided vehicles. Generally what they do is they travel a fixed path only, and they require infrastructure for the guidance and to figure out where they are. And the infrastructure there is going to be tapes, wires, or beacons or other fiducials that it uses to navigate and know where it is. They generally have more simple collision avoidance and are not as collaborative or as an AMR. So basically what you have here on the left, a little more less autonomous and more autonomous over here. And I'm not saying they're not autonomous, but that's kind of how they're laid out. In the middle here, we have QR bots. These are generally, it's based on the type of navigation. So they're QR code driven. They're using QR codes that are on the bottom of the floor, or not the bottom of the floor, but on the floor here, where the mobile robot's driving over that, and it scans that and it knows where it is in that grid. These are generally used at what you see in the, so Kiva-like solutions or goods-to-person solutions. And generally, they're in an area that has to be caged off, and people aren't allowed in. Now, they also are making improvements to that technology where they are making those more autonomous, and people can get in and be more operational with them. And then you have the AMR, so the autonomous mobile robot. That's designed to work safely around people. It's fully autonomous with onboard intelligence using a map that we set up when we first install these. So admittedly speaking, this is my background in the business we're in. We're selling AMRs. There's no infrastructure required here. It's easy to deploy. We can get them up and running within about 72 hours. And they're collaborative and work with people. And they're just around the corner if you want to take a look after this presentation. So now what I'm going to do is kind of walk through each one of these and kind of share the technology that's there and the use cases that they're used in. So a forklift AMR, generally what we're seeing in this space, it's AMR technology combined with the forklift form factor. And what I mean by that is generally you're looking at the tines that are coming out of a forklift. That's what gives it the forklift capabilities there. But in general, what we see is most providers are enabling a forklift with an autonomy stack or a navigation stack, adding that to that. Now, what we're seeing is that the competition here, or I guess the dynamics here, AMR vehicles are seeking to replace some of the AGVs that are out there. And what the reason for that is an AMR doesn't need the fiducials that an AGV would need. So that's less infrastructure that you have to install and less that you have to maintain. And the use cases for this are truck unloading and loading. Admittedly, right now, I've seen use cases live in the field with unloading. Loading is something that people are taking a look at in the future and is on the roadmaps and put away, which is taking from the dock and putting it into a rack there, and doing the opposite of that. Full disclosure, Zebra has made investments into both of these companies. This is Fox Robotics up top, and then Third Wave Automation down below here. And again, they have a booth over that way as well. So now, goods to person or shelf to person solutions, what these do, it was originally developed by Kiva Systems, which was then acquired by Amazon, which more or less set off like there was a whole trigger of activity once that acquisition occurred of more robotics companies getting into the space and driving new technology and advancements. So here what happens is the robot goes underneath the shelf. So generally what happens, you keep the inventory on the shelf, and the robotic system and the software knows where that item is or that SKU is in the grid there. And when it's called to be picked, the robot will go underneath the shelf, pick it up, and then move it over to a pick station where the person will pick off of that shelf. And then the robot takes it back out into the field again. Generally, these are the new term is QR bots. They're QR code driven. You'll see here the QR codes are on the bottom there, on the floor. Now, I've been in facilities where they're squeaky clean and those QR codes are nice. There's also been some that I've been in where they're not as clean and they still work. So it's a very viable technology. What we see is these are generally used at larger retailers and 3PLs in greenfield sites. What you'll see is this requires space. You have to put in the grid somewhere. And generally that can either be built into the system when it's built, or the warehouse when it's built, or you're retrofitting it, which requires taking out infrastructure there. But in general, as I mentioned earlier, they're caged in because they are QR code driven, so they're not looking for obstacles because there isn't supposed to be anyone there. And they're generally used for order fulfillment, e-commerce fulfillment. Person the goods. This is AMRs, the direct human picking. What they do is they will receive the order. You load up the robots there with bins. Some of them already have pre-configured shelving. That robot will go out into the field, and the humans will interact with the robot and pick where they need to, they'll be directed by the robot where to pick. In some cases, some vendors are also using handheld devices to help the worker navigate to where they need to be, and they get the direction from the handheld device to pick into that location. There are a bunch of different technologies out there, but that's in general what they're doing. The person is picking into that robot, and then once it's done, they cue the robot to go to the next pick location, or they cue to the robot that this order is done, and it takes it to a pack-out facility. So these are generally used in order fulfillment operations. We have seen them also being used in manufacturing, where they're bringing goods to a line as well. Because you can go pick your inventory and then, or your raw materials and compile them in the robot and then take them to a workstation. Tote to person, this is, well, so I'd say it's an evolution. Maybe one of their vendors would say something different, but it's kind of an evolution of a goods to person picking operation here. Here when you have the shelving stays static, it stays in the facility, or it stays in the grid, and the robot operates within the grid, and it's going to go and pick a bin off of that shelf, and then take that bin over to a pick station where a person will either pick out of the bin or take the bin and use that for order fulfillment. And then there are different variations on heights and that vendors can go to here as well. Here's another example. Well, here's an example of sortation AMRs. Generally, what they'll do is they'll either have a tilt tray on top, which will dump out dump out is probably the wrong technical term, but which will tilt out and discharge the product that's on there into a bin or another location. These also have, here we have a cross belt, which is a motorized belt here that's going to discharge that product in a location. They're generally used for sortation, and they can also be used for returns and replenishment. And there are a number of different vendors in this space as well. Here, this is cart transport. These can be used for put away from an ASRS, and in the manufacturing space for work cell delivery. Here what you're doing is the cart and the robot are decoupled, so you can stage the carts and build up the carts by putting product into those carts. And then the mobile robot will pick up that cart and take it to a destination. Here I actually, I just did a seminar on this upstairs about 15 minutes ago, but here's the situation where we worked with a vendor or a customer and we're able to increase their throughput by 25% and allowed them to regain some of their floor space by pulling out the conveyor that they were using. Next, there's conveyor top. Somewhat similar to a car connect in that we're moving a tote or a bin. The difference here is there's an integrated conveyor top here that's on top of it, which will discharge the bin at a location or into a conveyor. Now what that does is it eliminates a touch point in that it can automatically dock into a conveyor and discharge that bin. The difference with a cart connect is you're going to need someone to take it off of that cart and put it onto a location. With the roller top, you don't need that. It's going to connect and automatically discharge that. Now, we do have operations where people take off of these roller tops and it connects either on the downstream or the upstream to a conveyor, but it all depends on how you want to configure that operation. And these are used for order fulfillment, line side delivery, and we've also seen these in applications for kitting. Here's a scenario that another use case that we did with this. The person, this is for a distributor. What they're doing is they're picking down the aisles. Once they've done picking that bin, they come to the end of the aisle. They hit that call button. That signals to our fetch core, our robotic management system, that a tote is there for pickup. And the roller top will go over there and pick up this bin, and then it'll take it to a conveyor for discharge and shipping. Here we're able to save the walking time that the associates did, dropping that off at the conveyors, so about 35,000 hours per year, and increase their cycle time and regain the floor space. So what they actually did here they pulled out some of the conveyor and put in more storage in this facility. So that allowed them to better utilize that floor space. Here's another example of line side delivery using a roller top. Here, they were able to increase their capacity by 3x and improve their facility utilization, their floor space by 33%. And what the conveyor is doing here, the roller top is doing here, they're loading the raw materials onto the conveyor top, and that is going to a workstation, which you see that person behind there. She is sewing that product together, and when it goes there, it's scanned in here by the scanner, which reads the tote here and says what's in that, so it knows what's in that, what's been dropped off, and the MES is tracking how that's moving throughout the facility. Again, also when the person is done working, they discharge it into a tote, and then the robot takes it on to the next workstation. And what this allows you to do is free up the space and your workers to be more productive and stay into that workstation. Sometimes what we see is the person that's doing the workstation there, it will actually do the material movement, pushing it in a cart to or from a work cell. So this frees up the employee to stay focused on the value-added task that they have at hand. And additionally, sometimes what you'll see is they're set up with conveyor as well. And so this allows you to reclaim that floor space and put in more workstations that are connected by the AMR. And then conveyor has a limitation with linear bottlenecks, like it goes one direction. If that stops or there's a disruption there, you can't go any further. The AMRs in this case can navigate around, like if a bot stops, it'll navigate around that robot and be able to deliver that product to where it needs to go. And that applies to all the robots, AMRs in general. And that's the difference between like an AMR and an AGV. And then we also, there's mobile pallet conveyor. This is different than a mobile forklift. This is allows you to move the pallet by placing it on top of the robot. Generally what they do is you can pick it up using a P&D stand. What you see here, the robot's going underneath here. It's lifting up the pallet and moving the pallet off of that P&D stand. Generally, we're looking at it replaces manual forklift movement for long-haul pallet transport. And here it does require some additional infrastructure to put in that P&D stand. But the use cases here are put away, shipping lane delivery, and case picking as well. And then here's the scenario what we did for a customer. What they were doing, they were, this enabled their pickers to stay in the pick zone. They did their forklift picking. They were building mixed SKU pallets. And then they were dropping it off at the dock door. What they did was created an AMR superhighway, if you will, where they where the pickers they built their mixed SKU pallet, and then they dropped it off at a central location, and then the mobile robot took it to the dock door to where the persons who are operating the forklift put it into a truck. So that keeps the people operating the forklifts doing more value-added tasks, and the deadhead travel time is done by the mobile robot here. And here we're able to save them about 112 miles per day. That helped them reduce their travel waste by 16%. So generally what we advise is take a look across your work stream. And here's the process flow that you're moving through your warehouse or your manufacturing facility, and see where your pain points are and your bottlenecks are. And then get the data to help you analyze what's going on in your facility to see where you want to automate and how you want to automate it. And then take a look at the different technologies that's out there for you to use. So that's all I had to cover today. I know I went through that rather quickly. So if you have any questions, we have a mic here, so feel free to ask. Oh, yes, the answer is yes.
In theory, there is a AMR or a type of robot where you could receive in, let's say something simple like a case pick, complete your entire warehouse, and the only thing that we cannot do right now is get it into the truck. and we are working on that. Is that correct?
So, in theory, probably yes.
Okay.
I haven't seen a facility that has done that.
We do have labor shortage right now.
Right.
So.
Right. So yes. So I brought up the slide that kind of shows all that. There would probably be still some connection and transfer points where you would need some fixed infrastructure to make those transfers. Maybe it's conveyor or something like that between some areas, but in theory, it can all be done with a mobile robot.
And is there any constraints with carriers, whether it's on the inbound or the outbound, on what devices can go in and out of their equipment? Is that a challenge?
So in and out of a trailer. So that part I don't know is that
Okay.
as well. I mean, I'd defer to those that go in and out. There's definitely safety constraints that you have to comply with and whatnot. And then getting in and out of the dock door is generally one of the challenges because dock doors aren't always level and they're going to come in at different angles and whatnot. So generally you're looking at the angle that's you're coming in and out of.
And do you see your devices more in customers or 3PL, 4PL fulfillment type environments?
So if you look at this landscape overall, the larger adopter of the person to goods is 3PLs.
Yeah.
And the reason for that is they generally already have their infrastructure set up, their shelving set up. So this is an easier add to that infrastructure where you're not having to replace the infrastructure you have. We have seen adoption from goods to person players, but as I mentioned before, you have to pull out some existing infrastructure, so some shelving, and this replaces the shelving, the shelf that the robot is picking up. Here, what you're doing is you're generally going down the aisle that already exists and picking into that mobile robot. So with regards to the 3PLs, that's generally where we see most of the adoption.
Okay.
And we have seen 3PLs have adopted like some of the truck unloading as well.
Okay.
Yes.
How versatile and flexible are the autonomous forklifts today? Not with trucks, but in and out of racks, staging lanes, depths of staging lanes, things along those lines.
So I'm actually going to defer to the third wave guys on that. That is beyond my technical capabilities at this point. Yeah.
So I think it depends a little bit on the provider. From third wave's perspective, we're about as flexible as it comes. We have aisle width constraints, much like a manual vehicle, right? We'll get down to about a 10.5-foot aisle today. But part of our solution is incorporating what we call shared autonomy. It involves a remote operator being able to engage with a vehicle. So even if we're in a scenario where a human put a pallet away, has it really skewed in the racking, right? If the truck itself can't figure out how to handle that autonomously, we'll bring a human into the process remotely to execute that transaction and then send it back on its way autonomously.
And I did forget to mention, they are also deployed at, I don't know if you qualify them as shippers or 3PLs, but I'll let you.
Yeah, so we have relationships with both shippers and 3PLs, as well as on some of the CPG side.
To the other question that was asked earlier. Any other questions? All right. Well, thank you for coming.